Good afternoon all. We are from the last group, consists of me, Samsyatul Husna, Devi Aristia, Anissa Putri Penika, and Kemas Vigo. We would like to present about 5-axis machining. Next. And here is our table of content of our today's presentation. Consists of definition, advantages and disadvantages, features and functions, and also the applications.
For the first part is about the definition. What is 5-axis machining? 5-axis machining is the machine's ability to move a tool or a part in 5 different axes simultaneously. The 5-axis machining offers 3 linear axes, which is X, Y, and Z, and 2 rotational axes, which is A and B, that work together at the same time to achieve complex surface machining. The machines allow rotation on 3 linear axes of movement and rotation of the machine bed and tool head. These advanced capabilities of 5-axis machines require high cost because the machine is expensive and highly trained machinist is needed to operate the machine accurately.
And the next one is about the features and the functions. For the first part, there is spatial positioning. The majority of 5-axis tasks involve spatial positioning of the tool, which already generates an enormous gain in flexibility, as well as drastically reduce logistical costs by eliminating the number of tools and allowing use of standard files instead of fixtures. And the next one, there is simultaneous machining. The fascination with 5-axis machining comes primarily from the possibility of simultaneous machining and the unique degree of freedom this technology offers, with unlimited spatial machining possibilities and where geometries and counter characteristics are concerned. The third one is the tool guidance. In 5-axis machining, the milling tool is guided in 5 axes in relation to the surface of the component. The fourth one is the free geometrical orientation. Compared to the conventional milling process, the free geometrical orientation of the tool in 5-axis milling enables considerably shorter machining times. And the last one is the cutting speed. It has high-speed milling, defined as speed 5 to 10 times higher than conventional machining, has emerged as another technology trend within 5-axis machining that reduces the process force between the tool and the workpiece.
Next is the advantages and disadvantages of 5-axis machining. The first advantage is it can produce complex shapes with 5 axes, which is X, Y, and Z, and also additional rotation axis. It can provide an ability to make more complex and more detailed shape of the product. The second advantage is shorter cutting tool. With 5-axis machining's simultaneous machining movement, it can use shorter and more rigid cutting tools so that it can tolerate more pressure due to cutting process. Next is the first disadvantages of 5-axis machining, which is higher price. With bigger and more parts, it comes also with higher price, and it should be operated with a qualified operator, which means more price to be used. And then second is complex programming. Like we said before, that 5-axis machining use X, Y, and Z and rotational axis. That means when we create the program, it will be more complex and more longer time needed to create the program.
And here is the application of the 5-axis machining. The first is machining complex 3D shapes. For this application, the 2 rotary axes are used to keep the cutting tools at or close to 90 degrees to the surface of the workpiece. The CAD and CAM software that is used in this application has been improved very well. The design engineer's 3D drawing can be directly imported in the CAD system, and once it is imported, the programmer task is relatively easy. Choices in machining method are numerous, and the programmer can command the CAM system to progress from roughing the workpiece to finishing it with successively smaller cutting tools. The second is conventional machining of tilted surface. The five-axis machine are not always used for 3D works. Their two rotational axes enable them to machine sloping planes, a frequent requirement that the three-axis machine cannot meet. They can be used for many conventional tasks such as nailing, boring, rimming, tapping, and drilling, where the task axis is not normal to the machine table. Next. And here is our references. That's all about our presentation today. Thank you.